All right, so today we're going to talk about geometric sequences. So yesterday we spoke about arithmetic sequences, and those are special types of sequences where you have a common difference, where you're adding from one term to the next with the same value. A geometric sequence is a sequence that your initial term and your next term will have a common ratio. So if I want to build a geometric sequence here, I'll start with the term 2, and then I'm going to pick a constant ratio between the two. So I want to now multiply by, we'll say, 3. So I multiply by 3, I get 6. If I multiply by 3 again, I get 18. If I multiply by 3 again, I get the same term, the next term, and so on. So this would represent a geometric sequence. You would have a list of numbers that have a common ratio from one term to the next. Key here is it's being multiplied. Yesterday, we were adding or subtracting a constant term. So in order to figure out a certain term in a geometric sequence, we have a formula. Just like we did for the arithmetic, but it's a little bit different. So if we're looking for a certain term, it's a sub n, just like the arithmetic sequence formula started. But then it's, because it's a common ratio, it's the first term, a sub 1 means first term, times the common ratio raised to the n minus 1. A sub 1 represents the first term in the sequence. R is whatever the common ratio is. So in that other example right before, the common ratio for that question was 3, because I had to multiply by 3 each time to get the next term. And the n is the number of term. So if we're looking for the 10th term, n would be 10. Or if we're given the 10th term, n would be 10. And then a sub n is whatever number sits in that spot, in the nth term spot. So the number in the nth term spot. All right, so let me give you a geometric sequence and we'll just redefine the variables to make sure we're okay. All right, so here's an example of a geometric sequence. So when you see a geometric sequence, some of them are clearer to see than others. So you have to check first to guarantee. So we want to see what are we multiplied from one term to the next. So from here to here, it's pretty clear. 1 times 4 gives us 4. 4 times 4 gives us 16. 16 times 4 gives us 64. 64 times 4 gives us 256. So it's clear to see that this is a geometric sequence with a common ratio of 4. Now, if you didn't see that, you had trouble seeing what am I multiplying from get to one term to the next, you can always flip it. You can always say, take 256, divide by the term before, and you would get 4. And then you can verify that again. 64 divided by the term before gives us 4. 16 divided by the term before, which is 4, gives us 4. So you can see that the common ratio from one term to the next is 4. All right, so now we can plug into our sequence if they're asking us to find a specific term. So let's see. I'll say find the 11th term of this sequence. All right, so let's define our variables again. All right, so we have to remember that this represents a sub 1. This represents a sub 2 because it's in the second spot. This is a sub 3 because it's in the third spot. This is a sub 4. It's in the fourth spot, and so on. So we're looking for the term that sits in the 11th spot. So that would be a sub 11. So a sub 11 is what we're looking for. The first term, the term sitting in the first spot, is 1. So 1 goes in the a sub 1 spot. I'm just going to use parentheses to separate the a sub 1 and the r. The r, the common ratio, we confirmed that before, is 4. We multiply by 4 each time to get the next term. So 4 goes here. We're looking for the 11th term, So my n is my 11. Okay, and then we're just going to calculate this. So this is essentially 1 times 4 to the 10th. If you don't want to simplify it first and you want to throw it right into your calculator, that's fine. But 4 to the 10th is 1,048,576. So that's the term that would be sitting in the 11th spot of this sequence. And it makes sense that it's super large because you're multiplying by 4 each time. So this is going to get exponentially large. And that's why your geometric formula is an exponential. All right, let's try one where finding r is a little bit harder. All right, so let's look at this sequence. It's a little confusing because the numbers have commas in them as well. So I just tried to make the commas and the numbers a little bit smaller and the commas between the numbers a little bit larger so you could see the difference between the two. All right, so we have 28,697,814 and then 19,131,876 and so on. So this looks like it's kind of hard to find what's going on here. It does appear as the numbers are decreasing. I'm going to tell you this is a geometric sequence. So the best bet here, or your best bet here, is instead of trying a bunch of trial and errors, you could take any term in the sequence. So I'll take the second term in the sequence, a sub 2. And I'm going to divide by the term prior to it. If I divide by the term prior to it, I can find out what I need to multiply by the prior term to get the next term. So I took this term, second term, I divided by the one before it, and when I do that, I get 2/3. Or you get like 0.6. You don't want to chop the decimal off. So when you actually divide these numbers, you get 0.6666667. Don't chop the decimal off because that's your calculator rounding. That's why we just change it to a fraction. And then I can confirm that again. Say I took the third term in the sequence. I'll just go over here. The third term in the sequence. And I divide by the term prior to it. I'll get 2/3 again. So my common ratio here, my R, is 2/3. Okay, so the question will ask you to find a specific term. So let's find the 16th term in the sequence. All right, so let's get rid of this work here so I have some space. So we're plugging into the geometric sequence formula. So we have a sub, I'm looking for the 16th term. My first term is this crazy guy, 697,814 times the common ratio, which was 2/3, raised to the number of term minus 1. So 16th term minus 1. And now I'm going to plug this into evaluate to get my 16th term. Okay, so to evaluate it, I actually, just because the numbers are so large, I just put it in exactly how the formula looks. So I put that 28 million number in times 2/3 raised to the 16 minus 1 because I'm looking for the 16th term. And when I press enter, I get that the term in the 16th slot, a sub 16, is 65,536. All right, so you're going to try a few of these on your own. Identify your common ratio first. If you can't see it clearly like the problem before, which was pretty straightforward, take one term and divide by the one prior to it. That will get you your R. Your first term is your first term in the sequence. And then your a sub n is whatever term you're looking for. So for this question, I was looking for the 16th term, so I had a sub 16. All right, so check this out and ask me any questions on chat if you get confused.